Hello and welcome to week 2 of summer chem prep. We're going to stick with kind of the algebra, the math-based stuff this week before we get into more of the chemistry stuff in subsequent weeks. But this is really important, what we're going to talk about today, dimensional analysis, because of how much it comes up throughout the year. Okay, so a lot of the calculations that we're going to do in chemistry are all solved with dimensional analysis. So you may have done it before in maybe your algebra classes, but either way, if you have or haven't done this, it's probably been a while, so it's worth it to go back over it. Okay, so the reason we use dimensional analysis is because it gives us a way to very easily keep track of our units of whatever we're trying to calculate. Okay, so for instance, if you remember from last week, we talked about units and how they can cancel out, or what unit you would be left with at the end. So if I would do something like, something easy, if I would say you have x to the third up top over x on the bottom, right? You could easily say that would cancel to x squared, right? Because one of these x's is going to cancel on the top with the x in the denominator, and so you end up with x squared at the end, right? So that stuff's easy, but we're going to use that exact same concept in dimensional analysis. So the way we use dimensional analysis is we set up basically a train of fractions that are being multiplied by each other. Okay, and this could go on for however many fractions you need in order to get to your final answer. But what we're going to do is use these fractions in order to cancel out units that we don't want and bring in new units that we do want. Okay, so for example, let's just do an easy one. This is kind of the one that's always used when introducing dimensional analysis. So let's just say we are trying to go from the unit of seconds to the unit of minutes. Okay, so let's just say we have a problem where we're literally just trying to go from, 500 seconds and convert that to minutes. Well, the way we use dimensional analysis to solve this is we're going to put our given number and make that into a fraction. That's going to be the first fraction in your inevitable fraction train that's being multiplied by each other. Okay, so you'll put your given amount, 500 seconds, over 1, because we can make it a fraction just by putting it over 1, and it doesn't change the number. Okay, but then the idea with dimensional analysis is that our next fraction that we're going to put on to this fraction train should get rid of the unit that we don't want anymore and bring in a new unit that helps us get towards our final unit, in this case minutes. So you want to think of something that relates seconds to minutes. Now this is an easy one because everyone knows we have 60 seconds for every 1 minute, okay? But we're going to use that in order to cancel out this unit seconds. Now, where would we put the unit seconds in our second fraction in order for it to cancel with seconds in the first fraction? Good. We're going to put it in the bottom, right? So if it's in the denominator of our second fraction, it's going to cancel with the unit that's in the numerator of our first fraction. We can then put minutes up top because we know 60 seconds is 1 minute. Seconds would cancel, so that gets rid of that unit that we don't want. Minutes is what we're left with here, and so that would be the only thing we have to do in order to do this dimensional analysis problem from going from seconds to minutes. And you would end up just doing 500 divided by 60, okay? And that would get you your answer. So that's pretty simple, but it shows you the concept of using the fractions in order to cancel out units that you don't want and bring in new units that you do want. Okay, so let's do a little bit of a tougher problem. Actually, And this one's going to have a few more fractions, so I might go a little longer into this other board, but let's go from 6.25 days, and we're going to try to convert that. We're going to go from days all the way to seconds. Okay, so let's think about the fraction that we can first put here to cancel out the unit of days. Now, what do we know? Does anyone know off the top of their head how many seconds are in a day? Probably not. So we can't really go directly from days to seconds because we don't know how many seconds are in a day. But what we do know is that there are 24 hours in a day. So we could put days here in the denominator because that's what we want to get to cancel. And we can put hours up top. For every 24 hours is 1 day. Now days cancels. And then we just keep going. Right now we're in hours, but we need to get to seconds. You might not know how many seconds are in an hour, but you probably do know how many minutes are in an hour. So we could do hours here in the bottom because we want it to cancel. And we can go to minutes. Because again, we know how many minutes are in an hour. 60 minutes in 1 hour. Now hours cancels because it's in the numerator than the denominator. We're still not done because we need to get to seconds, but now we know a very easy conversion to go from minutes to seconds. 60 seconds in 1 minute. Okay? Minutes cancels. Now you are left with seconds, which is our goal to get to seconds. And so in order to calculate this out, all you would do is everything that's in the numerator, so 6.25, 24, 60, 60, you would put a multiplication sign in front of in your calculator. Anything that's in the denominator, you would just put a division sign in front of your number. Okay, so you could do this all in one swoop. You could do 6.25 times 24 times 60 times 60 divided by 1, divided by 1, divided by 1, divided by 1. In this case, you don't even have to do that because dividing by 1 is not going to change your number. Okay, but you would get this as 5, 4, 0, 0, 0, 0, 540,000 seconds in 6.25 days. Okay, so that's how we're going to use dimensional analysis. We're going to set up that fraction train and then use that to cancel out units that we don't want, bring in new units that we do want, until we eventually get to our final unit. Okay. This chemistry lecture brought to you by the memories of going places. Do you remember going places? Places. Okay, so now we're going to use dimensional analysis to kind of introduce another topic that is very important in chemistry, and that's metric units. So we are always going to use metric units in chemistry, never the US system, always the metric system. And hopefully you realize why the US system for units does not make any sense. It's based off of no common number, whereas the metric units are always based around the number 10. So there's consistency and it makes sense. So we are always going to use the metric units, which means we have to know a bunch of metric prefixes. Okay, so you know a bunch of them already. Think like centi, kilo, milli. You know, those prefixes that you put in front of the actual unit, like meters or grams, those are metric prefixes. So centimeters, kilograms, those are the metric prefixes that we need to know. Okay, so I'm going to list them out here. These are, I'm going to put the metric prefixes here, and then put the power of 10 that is associated with those metric prefixes. Okay, and the power of 10 will be all with respect to how many of the base unit you need in order to make one of the prefixed unit, okay? So when we say the base unit, what we mean is just regular old meters, regular old grams without a prefix on it, okay? So that's what we mean when we say the base. So it won't have a power of 10 associated with it because it's just the regular unit, okay? So the first one, I'm going to put big ones below the base and small ones above the base. The only one that I want you to know for the summer that's bigger than the base is kilo, okay? And the abbreviation for kilo, I'm sure you already know, is just a lowercase k. And you probably already know how many of the base unit, so think like meters, how many meters would there need to be in order to get to 1 kilometer? Good, it's 1,000. So if we put 1,000 in terms of a power of 10, that's just 10 to the third power. 10 cubed is 1,000. Okay? So that's the only one that's bigger than the base unit that we need to know. The other ones that I want you to know are centi, milli, and micro. Okay, so those are the ones that are smaller than the base unit. For centi, the abbreviation, I'm sure you already know for centi is a little c. The abbreviation for milli, it makes sense to make it little m. Okay, and then micro, it's another m word. We've already used m here, so we can't use that. So we're actually going to have to turn to a Greek letter called mu. But mu just looks like, it's basically a U with a tail on the front. Okay, it's like a lowercase u, but just a tail out front. I'll blow it up here. So it's like a U, and then you just put a tail on the front. Okay, so that's mu, and we will use that for micro. Now, I'm sure if I asked you how many centimeters it takes to make a meter, you would probably know because we have metric meter sticks always in our classrooms. And it would be 100, right? You know that. But again, this is how many of the base unit, so how many meters it would take to get to 1 centimeter. So it's kind of the opposite thinking. And so instead of 100, it's going to be 1 over 100, or 10 to the minus 2. Milli is 10 to the minus 3, and micro is 10 to the minus 6. Okay? So the reason I wanted to do this was to use dimensional analysis to do some unit conversions. Okay, so we're going to do 2 types. We're going to do an easy type first, and that is when we are going back and forth from one of the prefixed units to just the regular old base unit. Okay, so we could go from the base to a prefix or from a prefix to a base. Okay, so let me show you what I mean here. Let's do a conversion, let's say 423 centimeters, but we don't want the unit centimeters. We actually want to go to the base unit of just regular old meters. Okay, so let's use dimensional analysis to set up a problem like this as a unit conversion dimensional analysis. So the first step with dimensional analysis always is to put your given number with its unit over 1. Okay? And then we're just going to figure out what fraction we can use in our next fraction in order to get rid of centimeters and bring in a new unit. In this case, we want to get to meters. Well, that's why we have this table, because this will tell us what to fill in here. But we know in terms of units, we're going to need centimeters on the bottom so that it cancels. And because of this power of 10 that we have listed over here, the only thing that we can use those powers of 10 for is to go from the prefix to the base. Okay? So we're going to have to go to meters here because that is the base. Luckily, that's what we're trying to get to. Okay? So that satisfies our problem. And whenever you're going to fill in these numbers here, you're always going to put that number, that power of 10, with the base unit, okay? With the base unit. So all of these numbers go with the base unit whenever you're doing a conversion. So centi is 10 to the minus 2, so we will put 10 to the minus 2 next to the base unit. What goes next to the prefix always is a 1. It doesn't matter if the prefix would be up top here in the numerator and the base would be in the denominator. Like if we're doing another problem and they're switched, a 1 will still always go next to the prefix unit. Always, always, always. The power of 10 will always go next to the base unit. Okay? So that gets rid of centimeters. That gets us to meters, which is our goal here. And so we would just plug this into our calculator. It would be 423 times 10 to the minus 2 divided by 1 divided by 1. Again, you don't have to do that mathematically, but you would end up with 4.23 meters as your final answer. Okay, so that's kind of the simple one, going from a prefix to a base, or vice versa. But let's do a prefix to another prefix. Okay, this would be going from like micro to kilo, centi to milli, milli to kilo. You're going from one prefix to another prefix. Okay, now if we want to use these powers of 10, remember it has to go next to the base unit. So we are not actually going to be able to go directly from one prefix to the other prefix and still use these numbers. So unfortunately, you're going to have to make an extra step where we go from the old prefix to the base unit, then from the base unit up to the new prefix. Okay, so it's going to add one extra little step, but it still isn't too bad because you have all the numbers that you need listed here. So let's do this one. Let's say we have 6.1 times 10 to the 8th micrograms. Okay, so we're starting with micro, and we want to convert that to kilograms way down here. Okay, so let's use dimensional analysis. First step always is put your given amount over 1. So we have 6.1 times 10 to the 8th micrograms all over 1. Now, again, we're trying to get rid of the unit of micrograms, but we're going to have to first go to the base unit of grams. So our first fraction after the given amount will be used in order to get rid of micrograms to just go to the base unit of grams. Okay? Now, if we stopped right here, we would cancel micrograms and we would be left with just regular grams. But that's not what we want. So we need to keep going. So let's add one more fraction, because now we can go from the base of grams up to the prefix, our new prefix, which is kilograms. So we'll put grams in the bottom, kilograms up top. That's what we're trying to get to, and so that's the only fractions that we'll need. We know we're done when we get that final fraction to have the unit of our desired unit. Okay? So now we have the units worked out. Micrograms cancels, grams cancels, we're left with kilograms. So we're good in our units, we just need to fill in the numbers. We go to micro, and it's 10 to the minus 6th. It has to go with the base. So we'll put 10 to the minus 6th up top because that's where our base unit is. Remember, a 1 always goes next to the prefix unit. And then we'll come here to our next fraction, our final fraction. Kilo is 10 to the 3rd. Now look, our base unit is in the bottom this time. So 10 to the 3rd will go in the denominator, and the 1 always goes next to your prefix unit. That will go in the numerator in this case, and then we just have to do some math. 6.1 times 10 to the 8th times 10 to the minus 6th times 1 divided by 1 divided by 1 divided by 10 to the third. Okay? And so what you should end up getting, if you plug that into your calculator correctly, you should get 0.61 kilograms. Okay? And this is how we're going to set up a lot of problems in chemistry, but the easiest way to kind of learn it is with our unit conversions. And so this is how we are going to do these kind of harder ones. You're going to set up this fraction train, cancel out the units that you don't want, bring in the new units that you do. All right, that's it.